Chapter 2 gi chemical bonding gi makha chatharakpa oina khoi characteristics of ionic and covalent compounds yengsi. Among the khoi three types of bond ko electrovalent bond, covalent bond, and coordinate bond haina makhan ahum tamkhre. So adugi makha chatharakpa oina ionic and electrovalent bonds yengtang yengsi. Now here characteristics of the ionic and the electrovalent compound haibasi magi first point kari piki haba matamda ionic compounds are generally crystalline in nature ka akoi solid chi makhan ani lai ka solid che khoi na makhan ani thona khaidokpa yai kari kari no harga crystalline haba ma ACRY na irage aduga amorphous haba ma ko M O R ko P H O U S amorphous na ko O U R S amorphous ko ꯍꯥꯏꯕꯗꯤ ꯀꯩꯅꯣ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ꯑꯩꯈꯣꯏ ꯁꯣꯂꯤꯠꯁꯤ ꯑꯃꯅ ꯑꯩꯈꯣꯏ ꯆꯤꯅꯤꯒꯤ ꯇꯥꯏꯞꯇ ꯊꯨꯝꯒꯤ ꯇꯥꯏꯞꯇ ꯃꯥꯒꯤ ꯖꯣꯃꯦꯇ꯭ꯔꯤꯀꯦꯜ ꯁꯦꯞ ꯀꯔꯤ ꯀꯔꯥ ꯂꯩꯔꯒ ꯀꯣ ꯄꯥꯏꯕꯗ ꯑꯩꯈꯣꯏ ꯐꯤꯖꯤꯀꯦꯜꯂꯤ ꯇꯆ ꯇꯧꯕ ꯃꯇꯝꯗ ꯑꯩꯈꯣꯏ ꯀꯗ꯭ꯔꯛ ꯀꯗ꯭ꯔꯛ ꯂꯥꯎꯔꯒ ꯖꯣꯃꯦꯇ꯭ꯔꯤ ꯁꯦꯞ ꯍꯥꯏꯅ ꯂꯩꯕ ꯀꯥꯡꯕꯨꯁꯤꯡꯁꯤ ꯑꯩꯈꯣꯏꯗ ꯌꯥꯝ ꯁꯤꯝꯄꯜꯗ ꯀ꯭ꯔꯤꯁꯇꯂꯥꯏꯟ ꯍꯥꯏ ꯑꯗꯨꯒ ꯑꯃꯐꯔꯁ ꯍꯥꯏꯔꯒꯅ ꯑꯩꯈꯣꯏ ꯀꯩꯗꯧꯔꯕ ꯄꯣꯟꯁꯀꯨꯝꯕ ꯁꯦ ꯄꯥꯏꯕꯗ ꯌꯥꯝꯅ ꯁ꯭ꯃꯨꯠ ꯑꯣꯏꯕ ꯀꯥꯡꯕꯨꯁꯤꯡꯁꯤꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯀꯩ ꯍꯥꯏꯒꯦ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ꯑꯃꯐꯔꯁ ꯍꯥꯏꯀꯣ ꯑꯗꯨꯅ most of the ionic compounds ꯑꯩꯈꯣꯏ ꯀꯔꯤ ꯑꯣꯏꯒꯟꯒꯦ ꯍꯥꯏꯕ ꯃꯇꯝꯗ they are generally crystalline in nature ꯑꯣꯏꯒꯜꯂꯤ ꯍꯥꯏꯕꯗꯤ ꯉꯁꯥꯏ for example ꯑꯩꯈꯣꯏ ꯊꯨꯝꯒꯨꯝꯕ NaCl ꯀꯣ sodium chloride ꯁꯦ ꯀꯩꯗꯧꯏ ꯑꯩꯈꯣꯏ ꯄꯥꯏꯕꯗ ꯃꯥꯒꯤ geometry shape ꯂꯩꯔꯒ ꯀꯗꯛ ꯀꯗꯛ ꯂꯥꯎꯏꯗꯅ that is the crystalline in nature ꯍꯥꯏꯁꯦ ꯑꯗꯨꯅꯦꯕ so ꯁꯤꯁꯤꯡꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯗ which are arranged in a well defined geometric pattern ꯍꯥꯏꯁꯦꯀꯣ so ꯃꯥꯒꯤ ionic compounds ꯁꯤꯡꯁꯦ ꯑꯩꯈꯣꯏ ꯃꯥꯒꯤ ꯀꯩꯅꯣꯁꯤꯡꯁꯤ ꯑꯦꯔꯦꯟꯖꯃꯦꯟꯁꯤꯡꯁꯤ ꯑꯩꯈꯣꯏ ꯗꯦ ꯑꯥꯔ ꯅꯟ ꯗꯤꯔꯦꯛꯁꯅꯦꯜ ꯑꯣꯏꯒꯅꯤ ꯀꯣ ꯅꯟ ꯗꯤꯔꯦꯛꯁꯅꯦꯜꯗꯤ ꯗꯤꯔꯦꯛꯁꯟ ꯂꯩꯇꯕꯗꯨꯕꯨꯅꯤ ꯑꯗꯨꯒ ꯃꯣꯏꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯑꯦꯛꯖꯥꯝꯄꯜ ꯑꯣꯏꯅ ꯂꯧꯈꯠꯂꯕꯗ sodium chloride ꯂꯧꯈꯠꯄ ꯌꯥꯏ ꯀꯣ ꯁꯤꯗ sodium chloride ꯄꯤꯔꯤꯁꯦ now ꯁꯤꯒꯤ ꯁ꯭ꯇꯔꯛꯆꯔꯁꯦ ꯈꯤꯇꯪ ꯏꯝꯄꯣꯔꯇꯦꯟ ꯑꯣꯏ ꯀꯃꯥꯏꯅꯅꯣ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ꯑꯣꯀꯦ ꯁꯤꯗ ꯌꯦꯛꯏꯕ ꯑꯩꯈꯣꯏ ꯕ꯭ꯂꯦꯛꯁꯤꯅ ꯀꯩꯅꯣ ꯀ꯭ꯂꯣꯔꯤꯟꯅꯤ ꯑꯗꯨꯒ ꯔꯦꯗꯁꯤꯅ ꯀꯩꯅꯣ ꯁꯣꯗꯤꯌꯝꯅꯤ ꯀꯣ ꯁꯤꯒꯤ ꯁ꯭ꯇꯔꯛꯆꯔꯁꯤꯁꯨ ꯑꯩꯈꯣꯏ ꯑꯣꯜꯔꯦꯗꯤ ꯃꯃꯥꯡꯗ ꯍꯪꯈ꯭ꯔꯦ ꯀꯣ ꯑꯗꯨꯅ ꯁꯤꯗ ꯇꯥꯛꯅꯤꯡꯉꯤꯁꯤ ꯃꯦꯟ ꯑꯣꯏꯅ ꯑꯩꯈꯣꯏ ꯑꯥꯏꯟꯁꯤꯡꯁꯦ ꯑꯥꯏꯟ ꯃꯁꯤꯡ ꯅꯠꯇ꯭ꯔꯒꯅ coordination number ꯌꯥꯝ ꯍꯪꯒꯜꯂꯤ ꯀꯣ ꯀꯩꯅꯣ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ꯁꯤꯗ 1 chloride ion ꯀꯣ or 1 sodium ion ꯁꯨꯃꯥꯏꯅ ꯄꯤꯕ ꯃꯇꯝꯗ ꯀꯩꯗꯧꯔꯦ ꯁꯤꯒꯤ ionsꯤꯡꯁꯦ 1 chloride ion is surrounded by the 6 sodium ion 나 ꯀꯣꯏꯁꯟꯒꯅꯦꯕꯀꯣ 6 Na ꯀꯣ 6Na plus 1 ꯀꯣ ꯑꯗꯨꯒ again ꯁꯤꯒꯤ ꯑꯩꯈꯣꯏ sodium ion ꯁꯦ ꯑꯃꯨꯛ ꯀꯌꯥꯅ ꯀꯣꯏꯁꯟꯒꯗꯣꯏꯕ 6 chloride ion ꯑꯃꯨꯛ ꯀꯣꯏꯁꯟꯒꯅꯦꯕ ꯁꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ ꯑꯩꯈꯣꯏ coordination number ꯀꯌꯥꯅꯣ ꯍꯪ ꯇꯥꯔꯒꯗꯤ ꯀꯣ sodium ion ꯁꯤꯗ chloride ionꯀꯌꯥ touch ꯇꯧꯏ 6 so coordination number is the 6 ꯀꯣ ꯁꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ ꯑꯩꯈꯣꯏ sodium chloride ꯀꯤ structure ꯁꯤꯃ ꯌꯦꯛꯄ ꯍꯩꯖꯤꯟꯕ ꯗꯔꯀꯥꯔ ꯑꯣꯏ next second point ꯑꯩꯈꯣꯏ ionic compounds have high melting and boiling point ionic compounds ꯑꯩꯈꯣꯏ ꯀꯩꯗꯧꯔꯕ high melting and boiling point ꯂꯩ ꯍꯥꯏꯕ ꯀꯣ ꯍꯥꯏꯗꯤ ꯃꯣꯏ melting point melt ꯁꯧꯗꯣꯛꯄꯒꯤ ꯑꯗꯨꯒ boil means ꯑꯩꯈꯣꯏ ꯉꯁꯥꯏ liquid to ꯑꯩꯈꯣꯏ gas ꯇ ꯑꯣꯟꯕꯒꯤ pointsꯤꯡꯁꯦ ꯌꯥꯝꯅ ꯋꯥꯡꯉꯦ ꯀꯔꯤꯒꯤꯅꯣ ꯍꯌꯦꯡ ꯑꯦꯛꯖꯥꯝꯗ ꯍꯪꯕ ꯌꯥꯕꯁꯤꯅ why the ionic compounds ꯀꯣ have high melting and boiling points ꯅ ꯍꯪꯉꯛꯀꯗꯣꯏꯅꯤ ꯀꯔꯤꯒꯤꯅꯣ ionic compounds high melting and boiling point ꯂꯩꯔꯤꯁꯦ ꯀꯣ ꯃꯔꯝꯁꯤ ꯀꯔꯤꯒꯤꯅꯣ ꯍꯥꯏꯕ ꯃꯇꯝꯗ this is due to the strong electrostatic force of attraction between oppositely charged ion ko as a result of this large amount of energy is needed to break the bond and hence melting point and the boiling point are high ngasai akhoi sodium chloride lokhom matamda Na plus Cl negative so this is the ion ni ko ion ani se ke doge ha matamda mabani ki miracle labor interaction is very strong electrostatic force of attraction ne hai electrostatic force of attraction hai static means length ba hai ni ko electro means electrically charged bu positive negative charge bu ba ani akhoi ke dorba yam kanna chingchanari ba sakti si bo ko electrostatic force of attraction hai so sigi charge ion sing si yam kanna chingchanarabani na aina melt tawba natragana boil tawba haise it's a bond break tawdoini moigi maraka leiriba interaction du ai thugai ga doini ko aduna yam kanna chingchinaragadi moi thugai ge hai taragadi kedaraba large amount of ꯀꯣ energy ꯆꯪꯉꯦꯕ energy ꯆꯪꯉꯦꯕ ꯑꯗꯨꯅ ꯃꯔꯝ ꯑꯣꯏꯔꯒ ꯀꯩꯗꯧꯒꯦ ꯍꯥꯏꯕ ꯃꯇꯝꯗ they show high and high melting and high boiling point show ꯇꯧꯔꯤꯅꯦꯕꯀꯣ third point ꯑꯃꯨꯛ ꯌꯦꯡꯁꯤ they can conduct electricity in molten state and in their aqueous solution ꯍꯥꯏꯕꯗꯤ ꯀꯩꯅꯣ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ꯃꯣꯏꯁꯦ ꯑꯩꯈꯣꯏ ꯆꯣꯠ ꯆꯣꯠ ꯂꯥꯎꯅ ꯂꯩꯔꯕ ꯃꯇꯝꯗ ꯅꯠꯇ꯭ꯔꯒꯅ ꯑꯩꯈꯣꯏ ꯀꯩꯗꯧꯔꯕ ꯃꯍꯤ ꯄꯦꯠꯁꯀꯤ ꯇꯥꯏꯞꯇ ꯂꯩꯔꯕ ꯅꯠꯇ꯭ꯔꯒꯅ ꯃꯍꯤ ꯑꯦꯀꯣꯁ ꯁꯣꯂꯨꯁꯟꯗ ꯏꯁꯤꯡꯗ ꯌꯥꯜꯂ ꯂꯩꯔꯕ ꯃꯇꯝꯗ ꯀꯩꯗꯧꯒꯦ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ꯃꯩ ꯆꯠꯄ ꯉꯝꯃꯤ ꯍꯥꯏꯕꯅꯤꯀꯣ ꯃꯩ ꯆꯠꯄ ꯉꯝꯃꯤ next ꯃꯈꯥꯗ ꯑꯩꯈꯣꯏ fourth point ꯑꯃꯨꯛ ꯌꯦꯡꯁꯤꯀꯣ ionic compounds are usually soluble in water and other polar solvents ꯍꯥꯏꯕ ꯍꯥꯏꯗꯤ ꯀꯩꯅꯣꯗ ionic compoundsꯤꯡꯁꯦ waterꯗꯁꯨ ꯇꯨꯝꯃꯤ and other polar solvent ꯀꯩꯒꯤꯅꯣ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ionic compoundsꯤꯡꯁꯦ ꯑꯩꯈꯣꯏ charge ꯄꯨꯏꯀꯣ ꯑꯗꯨꯅ charge ꯄꯨꯏ so charge ꯄꯨꯕꯁꯤꯡꯁꯦ ꯑꯩꯈꯣꯏ mostly waterꯁꯤꯁꯨ ꯀꯩꯗꯧ ꯍꯥꯏꯕ ꯃꯇꯝꯗ polar solventꯅꯤ and other polar solventsꯤꯡꯗꯁꯨ ꯑꯩꯈꯣꯏ ꯇꯨꯝꯃꯤ but insoluble in Canada organic solvent like benzene ether carbon tetrachloride kerosene ꯌꯥꯏꯀꯣ ꯃꯣꯏꯁꯤꯡꯁꯦ organic solvent ꯍꯥꯏꯔꯒꯁꯨ ꯈꯪꯅꯩ ꯑꯗꯨꯒ non polar solvent ꯍꯥꯏꯔꯒꯁꯨ ꯈꯪꯅꯩ ꯑꯗꯨꯅ ꯃꯔꯝ ꯑꯣꯏꯔꯒ non polar solventsꯤꯡꯗ polar compoundsꯤꯡ ꯅꯠꯇ꯭ꯔꯒꯅ ionic compoundsꯤꯡꯗꯤ insoluble ꯑꯣꯏ ꯍꯥꯏꯕꯀꯣ ꯁꯤꯐꯧꯅ ꯑꯩꯈꯣꯏ characteristics of the ꯑꯩꯈꯣꯏ electrovalent bond or ꯑꯩꯈꯣꯏ ionic bondꯒꯤ ꯃꯥꯒꯤ characteristics ꯂꯣꯏꯔꯦ now ꯑꯩꯈꯣꯏ covalent bondꯒꯤ ꯃꯥꯒꯤ formation ꯇꯧꯕꯁꯤꯗ ꯑꯩꯈꯣꯏ some example ꯈꯔ ꯌꯦꯡꯁꯤꯀꯣ okay ꯁꯤꯗ example ꯈꯔ ꯄꯤꯔꯦ ꯀꯣ ꯁꯦ ꯑꯍꯥꯟꯕꯗ chloride molecules కి ꯄꯤꯔꯦ ꯀꯣ then from the chlorine ꯁꯦ ꯃꯥꯒꯤ electronic configuration 2 8 7 ꯑꯅ ꯏ so outermost cell ꯗ ꯁꯤꯒꯤ 7 ꯁꯤ ꯏꯕꯤꯔꯦ then 2 8 7 ꯑꯗꯨꯒ 1 electron ꯊꯥꯡꯗꯣꯛꯑꯒ ꯁꯤꯗ ꯀꯩꯗꯧꯔꯕ sharing ꯇꯧꯃꯤꯟꯅꯔꯦ this is the covalent bond ꯅꯤꯀꯣ ꯑꯗꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ ꯑꯩꯈꯣꯏ HCl ꯁꯨ bond form ꯇꯧꯔꯦ then methane formation ꯇꯧꯔꯦ ꯀꯣ then ꯑꯩꯈꯣই water formation ꯇꯧꯔꯦ then ammonia ꯀꯣ ammonia ꯁꯤ ꯌꯥꯝ important ꯑꯣꯏ then sida akhoi multiple covalent bonding haise covalent bonds sing se akhoi multiple bond formation tawba ngami sida bond pair of electrons and the lone pairs na yaw si kaino hai matam da say for example ammonia sida ta harasi ko koina ammonia sida nitrogen ki outermost shell da 5 electrons leibasi 1 2 3 sigi 3 electrons sing sidi ke daraba they share with the kanada hydrogen ga ko adu sida remaining 2 electrons sibuna khoi kai kauge ha matam da lone pair kawi nitrogen masada atopaga bonding tawdabida lemhorisina ko aduga sida hydrogen ga share tawraga changriba electron sibuna khoina kai hara khanage ha matamda bond pair hai so sigi bonding se khoi covalent bond da multiple bonding ami kamaina no hai matamda single bond leba yai ko means only 2 electrons khak share tawta di ko 2 electrons khak join sharing tawta di that is single bond then 4 electrons share tawta di 4 electrons share tawta di that is the double bond ko aduga 6 electrons haina 6 electron bonded tawta di ke daraba akoi adubuna akoi triple bond har khangne now koi example okay example de yengsi single bond gi diam layer double bond da akoi oxygen da ko oxygen ani se oxygen gi my configuration je 2 6 ne eko aduna outermost cell da 1 2 3 4 5 6 da su ke daraba 2 6 so 6 6 outermost cell se ma sharing taw matam da ke daraba electron mari share taw matung da khoi sida su electron mari ko mari share taw okay mari share taw matung da double bond formation ngame then triple bond formation da na nitrogen example da sida kamai leba 2 5 yai ko 1 2 3 4 5 sida su 2 5 aduna sige 5 sidagi out 3 3 thangtore 1 2 3 1 2 3 ko aduna si 3 ga 6 se sharing tomina means triple bond formation ko ko okay si leijaraba matungda akhoi makhada akhoi coordinate or dative bond ge mu yengsi ko coordinate or dative bond se akhoi sometimes magi usual representation of coordinate bonds se akhoi sigi arrow sina mean toy id this double arrow head means kaino ha matamda 2 electrons ko 2 electrons donate away have ni aduna koi dative bond si kanada example kanada phange ha matamda koi ozone da ko O3 ozone da phange magi example sta ahanba oxygen ani sharing dominate then another oxygen amaga mu share torakanda these two electrons se kanana pithorakpano asigi two oxygen atoms in here ko si 1 2 3 ne nai maming thoja that these two oxygen atoms na akoi electron pair se pithore aduga this type of bonding form to this is the kari coordinate bond ko ko then atopa some more examples ta koi hydronium ion lere ammonium ion lere ko si water da so ko sharing tor mutung da H plus ama ka share tawge hai tadi oxygen should donate two electrons to the canada H plus the H plus the electron am ta yauza de dana aduna my bond representation type so sai tawgane ko representation type so tawgane then akoi ammonium ion su chamanare ko my characteristics of the covalent substance yang si ka ko physical state covalent compound does not exist as ion, but they exist as molecules. Molecules so exist away, ion so exist out there. Aduga moigi marakta layisi kaino weak intermolecular force between the molecules. Molecules into marakta kadraba yamna weak over intermolecular forces lay and generally they exist as a liquid or gas at the room temperature. Room temperature to the kedoke hamatam the molecules ma'am sing to marakta lay interaction to yam son means bit akoi bonds into flexible lay I have ni ko aduna mainly kanada phange hamatam the liquid and a gaseous state of fungal level ko aduga boiling point su kadore their interaction are very weak so low melting and boiling point force of attraction between the molecules together they are very weak ko aduga energy yam changroi dudi se comparatively small amount of heat energy is required to overcome this forces yai ko akoi moi de leiriba forcing do koi thukage hai taragadi kedraba energy yam changde have then solubility amu yengse they are sparingly soluble in polar solvent. Havdi kaino hamatamda polar means akwai del positive and del negative labor. Let's say for example water. Yaiko water is akwai na O H although this is the covalent bond adubu akwai oxygen sin hena electronegativity wangbanina mangonda electron se singsanganeba aduna so in a polar form the lay taragadi sida akwai sparingly soluble means khaji tumme habani ko aduga but in soluble in the non-polar solvent akwai covalent compounds si akwai non-polar solvent da dikadorba it's a highly soluble oil like benzene gumba carbon tetrachloride gumba kerosene gumba moi da dikadorba soluble oil habako conductivity dikadore they cannot conduct electricity mai chatpa ngamde kaigino hai matamda they are made up by the neutral molecules or not ions sing na semba nateba molecules sing na akhoi neutral molecules sing na sagalakpanina mase mai chatpa ngamde habni ko